and is often proven using the image of squares drawn on the sides of a right-angled triangle. Now, I would be willing to wager that I am not the only one among us who has, at some point in the past at least, has not wondered why this representation works. We can see the squares adding up in front of our eyes, but we do not fully understand the mechanics behind it all. Surely there is a more conclusive proof that will elucidate us more lucidly. As it turns out, Pythagoras' theorem has more known proofs than any other mathematical concept. In fact, the book The Pythagorean Proposition by Dr. Elisha Scott Loomis contains 370 completely different proofs for the theorem. So, surely there is the perfect proof for anyone. Here is one which I rather like, which uses algebra rather than purely visual magic. Imagine 4 identical right-angled triangles with legs A and B, and hypotenuse 4, or C, arranged in a square so that the side of the square is of length A plus B. There are 2 ways of calculating the area of the square in the middle. The first is simply to multiply the side C by itself. The second is to take the area of the larger square and subtract the area of the 4 triangles combined from the total area. So the area of the square in the middle can be expressed either as C squared or as A plus B squared minus 4 times AB over 2, which simplifies to A plus B squared minus 2AB. So because these equations both give us the area of the central square and thus are equal, we can write that A plus B squared minus 2AB equals C squared. After expanding the bracket of A plus B squared, we get A squared plus 2AB plus B squared minus 2AB equals C squared. We can cancel out the plus 2AB with the minus 2AB, thus giving us A squared plus B squared equals C squared. Isn't that satisfying?